Okay, parametric equations, we carry on. Points of intersection today. So hit pause, make some notes. When you're ready, hit play again. So this is our example today. We've got our curve in red here. The curve is C, and it's made up of these parametric equations. X equals at squared plus t, and y equals a brackets t cubed plus 8. T is in the reals. A is a non-zero constant. It's actually worth highlighting that. It's a useful bit of information. If I can find the highlighter, there it is. A is non-zero constant. Okay, just get my pen back. Right, given that C passes through the point minus 4, 0, which is here, find the value of A. So I want to find the value of A, and I know that C passes through this point, so I've got the X value. What's the Y value when it crosses the X axis? That'd be 0. So the coordinates here are minus 4, 0. That's a 4 there. So minus 4, 0 are my coordinates at that point there. I know Y is going to be equal to 0. So if I equate this equation to 0, that's going to help me find T. Once I find T, I can sub it back in here because I know X is equal to minus 4, and I've got T. I'll only have one variable, well, one constant, one term that I don't know. So let's try that. So hit pause, write the question down, and when you're ready, hit play again and we'll try and solve it. So we're going to try and solve or find A using these coordinates that we've been given. So we know that we've been told y is equal to a brackets t cubed plus 8, and we know where it crosses the x-axis there, y is equal to 0. Where the curve crosses the x-axis, y is equal to 0. So we can say, well, that implies that a brackets t cubed plus 8 is equal to 0. So that means that either a is equal to 0 or t cubed plus 8 is equal to 0. One of them has to be equal to 0 to give us 0. Now, we know that a is a non-zero constant. We actually highlighted that earlier. So a can't be 0. So therefore, t cubed minus plus 8 is equal to 0, which means t cubed is equal to minus 8. And if you cube root both sides, t is going to be equal to minus 2. So we've got a value for t equals minus 2. Now, I know, I'm just going to switch color of the pen to make it a bit clearer where we're moving on. I know x is equal to at squared plus t. And I know at this point here, where it crosses the x-axis, even, x is equal to minus 4. So, and I know what t is now, if I can find a. So that implies that a times minus 2 squared plus minus 2 is equal to minus 4. Can solve that. So that'll be 4a minus 2 is equal to minus 4. I'm carrying on working over here. 4a is equal to minus 4 plus 2 for a equals minus 2. So a is going to be equal to minus 2 over 4 or a half. Minus a half. So that's part A done. I found the value of a. So we've used these coordinates to help us and sub them in that equation. So hit pause, make some notes, and then we're going to look at finding the points A and B next. Okay, so section B wants us to find, what does section B want us to find? Find the coordinates of the points A and B where the curve crosses the y-axis. So where the curve crosses the y-axis, there and there. So where it crosses the y-axis, what's the value of x? X is equal to 0. So we've got our equation, parametric equation, x is equal to at squared plus t. We know x equals 0, so that means that at squared plus t is equal to 0. I know what a is, so minus a half t squared plus t is equal to 0. Factorizing, you can see a t is common to both of those, so t brackets minus a half t plus 1 is equal to 0. So that implies I've got two values for t. Either t is equal to 0 or minus a half t plus 1 equals 0. And from here, that means that minus a half t, or actually, let's leave the 1 on this side. Just rub that out. Leave the 1 on the left hand side, and we'll work on the right hand side then. So if I leave 1 here is equal to a half t, that means that t is equal to 2. So those are my two values of t. I know x is equal to 0 at both those points. Now I can find my y value. I know what a is, I know what t is. So let's do that. I think I'll change color. So when t equals 0, y is equal to a brackets t cubed plus 8. So let's put the values we know. Minus a half brackets, that's 0 plus 8. So minus a half 8, which is going to give us minus 4. And in the second place, so that's going to be a minus 4 there. When t equals 2, y is equal to, let's write the equation first, a t cubed plus 8, and now we can sub in the values we have. A is minus a half, t is 2 cubed plus 8, so it's going to be minus a half. 8 plus 8 is 16, so it's going to be minus 8. So our second coordinate is minus 8. So just to conclude, coordinates, just make sure we're explicit about writing it. A is given by 0 minus 4, and B is given by 0 minus 8. Job done. Hit pause, make some notes, and when you're ready, hit play again and we'll look at another example. Okay, with this example, we're given parametric equations x equals t squared and y equals 4t, and then we've got a line that meets this curve at the point A. Find the coordinates of A. So what we can do is we can take our equation here, which we've been given, x plus y plus 4 equals 0, and change the parameters and put it in terms of t. That's going to give us the quadratic. So let's do that. Oop, I've still got a blue pen. Let's just change that to red. X plus y plus 4 is equal to 0. Let's change the parameters then. X equals t squared. So t squared plus y is 4t plus 4 is equal to 0. We can factorize that. T plus 2 and t plus 2, or t plus 2 squared. I'm sure you spotted that, which implies then that t is equal to minus 2. So we want to find the coordinates of A, so we can just sub for t back in this equation here. So when t equals 2, oops, minus 2 even, x is equal to minus 2 squared, which is equal to 4, and y is equal to 4 times minus 2, which is minus 8. So that's our first, well, those are our only coordinates. There we go. So we've got 4 and minus 8, and that's A. It's quite straightforward. Hit pause, make some notes. When you're ready, hit play again. We'll look at another example. Okay, this example then, we've got that curve on the right given by the parametric equations. X equals cos t plus sine t and y equals t minus pi over 6 all squared. And that ranges between minus pi over 2 to 4 pi over 3. And we want us to find a point where the curve intersects a line y equals pi squared. So given that, we can find t. Pretty straightforward really. We can equate the equation of the line and the equation for y of the curve. So hit pause, make some notes, sketch the curve, and when you're ready, hit play again, and we'll equate those and find the point. Right, so we've got y is equal to t minus pi by 6 squared. That's one equation. And we've got y equals pi squared. So you can equate 1 and 2 to help us solve for t. So that will give us then t minus pi by 6 squared is equal to pi squared. So if you take the square root of both sides, then we get t minus pi by 6 is equal to plus or minus pi. So t is equal to pi by 6 plus pi, or pi by 6 minus pi, which gives us two answers then. Let's see, I could write it up here. So that implies then that either t is equal to 7 over 6 pi or minus 5 over 6 pi. Now, if we look at the range of values that t can take, it ranges from minus pi by 2 to 4 over 3 pi. So while this is in the range, this one is not. So it cannot be that value. So t is equal to 7 over 6 pi. So hit pause, make some notes, and when you're ready, we're going to find the coordinates then for the points of intersection. And so to find the coordinates of the points of intersection, let's change pen, let's go blue. And we know that x is equal to cos t plus sine t. So let's sub for t. So it'll be cos 7 over 6 pi plus sine 7 pi by 6. And I think the easiest way to do this is to actually just plug it in the calculator. And make sure you have a go at this, but it should give you minus 1 plus square root of 3 all over 2. So the coordinates then, for completeness, are given by minus 1 plus root 3 over 2 for the x coordinate, and the y coordinate is pi squared. Okay, hit pause, make some notes, and then we look at B, part B. Okay, and then section B says find the coordinates of the points A and B where the curve meets the y-axis. So this is very similar to the previous example where it meets the y-axis. We know what the value of x is going to be. It's going to be 0. So let's get that x equation. What's x equal to? Cos t plus sine t. And where it crosses the y-axis is equal to 0, so that implies then that cos t plus sine t equals 0. Or I could say cos t, tell you what, let's leave the sine t on this side. Sine t is equal to minus cos t. Now then, how can I solve that? I'm going to divide through by cos t. So I'm going to have sine t over cos t is equal to minus 1. Sine over cos is tan, which is handy. So tan t is equal to minus 1. And if I use my calculator then, I get t is going to be equal to minus pi by 4. Which is fine, that's within the range. If I add 180 degrees to it, so I add pi to it, I get 3/4 pi. And those are the two values I can use. So I know x is equal to 0, and now I need to find out what y is going to be, to find my coordinates for A and B, which change to blue. So when t is equal to minus pi by 4, I know y is equal to t minus pi by 6 squared. So subbing for t, I'll have minus pi by 4 minus pi by 6 squared. If I work that out on my calculator, I should get, well, you should get 25 pi squared divided by 144. Similarly, when t is equal to 3/4 pi, y is going to be equal to, let's write the equation out, t minus pi by 6 squared. Subbing for t, I got 3 over 4 pi minus pi by 6 squared, and working that out should get 49 pi squared divided by 144. So that gives us coordinates then, let's write it here, for A of 0, 25 pi squared by 144, and B of 0, 49 pi squared divided by 144. Good. Hit pause, make some notes, and when you're ready, hit play again, and you can attempt some questions for me. Okay, some questions. For questions 1 and 2, I'd say left hand side of the page, so ACE, ACE, and then maybe odd questions then, because they're quite similar. And depending on how confident you feel then, maybe jump to question 10 and 12. Okay. But there are 17 questions, quite a lot. Depending on how your confidence grows, you don't have to do all of them. Good luck.